So in this video, I'll be running through how to build yourself a DIY Keepkey. The Keepkey is a hardware wallet that's actually been around for quite a long time. It originally started out life as a Trezor clone, and while its support has been a bit all over the place in terms of its official software over the years, it is very well supported in things like HWI and works really well with things like Sparrow, Electrum, and so on. And although the Keepkey is open source on the software side, on the hardware side there actually isn't documentation or schematics or anything like that available. Fortunately, we can just reverse engineer it. So let's get going. And if you haven't already done so, hit subscribe, and that way you can stay in the loop for content I make to help you find your way in the crazy and often hostile environment that is cryptocurrency. Now, just before we get into anything else, for those who might not be familiar with the Keepkey, basically it is a very simple device, just has a USB port on the bottom, has one button on the top, and basically just has a large display on the front. So basically in terms of the hardware, we know that this is a Trezor clone, we know it has one button, and the easiest way to work out the MCU and the screen would just be to crack this open and have a look inside. And fortunately for me, Aussie Hash actually did one of these teardowns all the way back in 2015, so we can have a look at what is inside the device without having to rip it open. And we can actually see here that the MCU that it is using is this one here, so the STM32 F206 RGT6, and that we're going to need 1 megabyte of flash. And what that means is we can actually get away with using this developer board here, the STM32 F405 RGT6. This has 1 megabyte of flash. It's the same one that I used in my Trezor 1 DIY video over here. And basically, if we just tip everything out in there, this is actually a nice and small low-cost board that also has a USB-C connector on there as well. So that is nice and actually an improvement over the original Keepkey once we get this thing going. Now, in terms of the display, apparently it's a 256 by 64 3.12 inch OLED. And this is another teardown by Stellar, so let's have a look. Okay, this is great. So yes, that is the main board and that is the display just there. And I had a quick look to see what I could find on AliExpress that might be similar, and I actually found this display here, which is the same size, the same resolution. So I ordered some of these and they showed up, and when I tested it out, it did in fact work. So this is the screen we'll be using, though its connection here is a bit different to the SPI that we use on the Trezor one, but I'll show you how to do that when we assemble it. And then finally, for the button on the device, we'll just stick with a standard sort of push button here. But the advantage of this board that I'm using here is it actually has a pull-up resistor soldered onto the board there, and that will actually matter when we get this running. So for this first one, I'm actually just going to connect it onto pin headers, just because it makes it nice and easy for me to show you what I've done. And so first thing I've gone and done is just solder the pin headers that came with it onto the board. So that is our board. This screen already came with these pin headers soldered onto there. Unfortunately, this didn't come with any documentation. These pins weren't exactly labeled in any sort of useful way. So after having a bit of a dig around online, I did find a pin out for the connector on the board itself. Basically then it's just a case in having a look at the source code just to see which pins are being used to drive the display, and then I could connect it all up. And to save you the trouble of doing all that, I put a diagram on how to connect it all up on my GitHub here. So I'll just wire this up. Okay, so that is all connected, making doubly sure that you've got your power and ground pins the right way around on the board. Everything else is pretty much forgiving if you get them around, but just make sure your power is the right way. And if we just have a look in keepkeybutton.c, we can probably see what port it's on. Yep, there we go. So the button is on channel B, port 7. Basically we're going to hook this up to B7 on the MCU board here. Now the one thing that's interesting with the Keepkey firmware is they have not used the internal pull-up resistors inside the MCU, which means we need to provide one of our own. Fortunately this board here does that. So essentially, if you've got one of these boards, we're just going to actually ignore the VCC and ground that is written on here. So basically for the button, I'll be taking the ground output, that's this purple one here, and just putting that to 3.3 volts. We'll basically take the VCC pin on the button and actually put that to ground. And what we will do now is we will put the button output into B7. Alright, so we've wired up the hardware. Let's put some firmware on here. So basically the process for building and flashing the firmware in this video will be exactly the same as what was in my video for doing a DIY Trezor 1. We're just going to use STM32 Cube programmer, and I'll run through how to install it in this video here. And we're also going to be using Docker and Windows subsystem for Linux, and I've run through how to install Docker in this video over here. If you feel like building everything from source is overkill, I've also just put the pre-compiled releases for both debug and release onto a Keepkey DIY GitHub here that you could just flash directly using either OpenOCD or STM32 Cube Programmer. So I've got STM32 Cube Programmer installed and running. I've got Docker Desktop running as well, and I will just be using Windows subsystem for Linux. So we're going to head over to the Keepkey Firmware GitHub. So basically what we're going to do is I'll just copy the repository there. So firstly, we're just going to clone the repository. There we go. And I will just make sure I am also checking out the latest release. I'll just copy the tag for that release, and I'll just move into the folder that I just downloaded. And now we'll just say git checkout. That'll switch us to make sure we are running a version of the repository that matches this release. We're going to follow a similar process here for verifying published binaries. So we'll just update all of the submodules in there. I'll paste that there. And this right here is the important place where you need to make sure you don't simply copy and paste the process for building production firmware. Basically, rather than use this command here, we're going to run a similar script, but it's actually for a debug build. So we're going to copy the first part of that up to device. We'll just paste that into there. And if I just hit tab on the keyboard, you can see it actually showed me the two different files that are in there. So rather than run release.sh, we are going to run debug.sh. If I just right click on that, paste it there, and then hit enter, it's going to build us the debug firmware. And that is done. So basically I'm just on Windows using Windows subsystem for Linux. So if I go into the home folder of that WSL environment, go into the Keepkey firmware folder, that's the one I just downloaded, and go into the bin folder, which has been newly created, I can see all of the firmware files that are now there as a result of that build. And while there are no instructions for how to flash this, if we go into scripts and load all, we can see the different scripts that are called to load the Bootstrap, Bootloader, and variant parts of the firmware. And this basically tells us the different memory offsets that we need to use when we upload these files using STM32 Cube Programmer. Now, one of the nice things about this development board in particular is if I connect the USB-C connector with this B0 button held down here, it will actually put it into what's called DFU mode, which lets me program it. So I'm going to hold down that middle button, which is B0, and just connect this to power. Okay, so that red light has lit up. So now over here in STM32 Cube Programmer, we've got this connected in DFU mode. I'll just change that to USB because I want to connect this over USB mode. I'll hit refresh, and there we go. So we can actually see it's found USB 1, which is this device here. And if I say connect, it'll take me online with this MCU. So in terms of flashing the firmware, basically what I'm going to do is go onto this erasing and programming, and the very first thing I'm going to do is just click full chip erase. There we go. So this chip has now just been wiped, so we can start flashing the firmware. Okay, so the next thing we're going to do, which is very important, is unclick run after programming, because basically we're going to have to flash several things onto this device, and we don't want it to simply reboot and start running as soon as we flash the first one. I just built this on WSL, so we'll just browse to where we built the files that I showed you just before. Keepkey firmware bin. Alright, so basically these are the files we're going to flash. The first one we're going to flash is this one here called bootstrap.bin, and basically we are just going to flash this one at this address here. So we'll just say start programming. That one's really quick. So the next thing we are going to flash is the file for the variant. So you'll notice here there's all these different variant files, and basically these are just the different logo that gets flashed up when you first boot the device. And these are just for various different branded versions of the Keepkey that were made available through the years. Which one of these you choose doesn't matter. For example, I'll just choose the variant fox.bin. Now the address we're going to flash this one at is actually this address here, so it's actually a different address to what we had before, and we'll just say start programming. So we put the variant on there. Now we actually flash the bootloader, so I'll choose bootloader.bin, and we'll just change this from a 1 to a 2. That's where the bootloader goes, and I'll say start programming. There we go. And now we'll actually flash the firmware itself. So now we'll choose this one here, so firmware.keepkey.bin, and we're going to change that 2 there to be a 6, and then we'll say start programming. Okay, and we've done all of that correctly pretty much. Now if I unplug this device then just plug it back in without pressing any buttons down, it should jump straight into this screen here, which it has. So we can actually see here that it's giving us a warning that the firmware is unrecognized, but this is good. This verifies that our screen has been connected correctly. And if I press that button down, if I hold this button down, you'll see that it ticks it and takes us through. And there we go, welcome to Keepkey. So you'll see here, it actually says debug link here, and we are in debug mode. So we could use this with just Electrum and something like that. Though if we are planning to use this to store funds, we really should use this with a version of the firmware that has been locked down. So now that we have verified everything works in terms of the hardware, the assembly, and so on, we can have a look at locking this device down. Now, before we run through how to flash the stock firmware onto your DIY device, I just want to talk a little bit about the bootloader, because there's some important concepts here you need to understand to make sure that you can do this properly. In the context of Keepkey, a double SHA-256 hash of the part of the memory on the microcontroller that stores the bootloader is being run, and it must match one of the checksums here that corresponds to different recognized, known and safe versions of the bootloader. And basically, if the retail firmware on your Keepkey doesn't see one of those approved versions of the bootloader, it won't run. So we need to make doubly sure that the bootloader we are going to flash matches exactly one of these images that the firmware will be looking for. In terms of Keepkey, there are three ways that we can get this bootloader. The first is we can build the bootloader from source, though using the release tag of the bootloader version, not the major firmware version. The second way we can get it is to go back through some of the older releases on the Keepkey firmware GitHub and just grab something like the 2.0 bootloader, which is there. Or we can manually extract the firmware image from the BL updater.bin files that are distributed by Keepkey. So given that we already have our environment set up to build our firmware from scratch, I'll be running through how to build the latest version of the bootloader, how to verify that that is correct, and how to flash that onto the device. And just for the sake of convenience, I've actually put all of the files that I built for this video on my Keepkey DIY GitHub, so you could actually just grab these and flash them yourself, as well as verify that all of these deterministically match what they should if you build it on your own system. All right, so we're back on the firmware GitHub. And what we're going to do is we're going to go onto the releases page, and we are actually going to click on tags. And what we're going to do is scroll down and see when we can find a tag for the most recent bootloader version, bootloader 2.1.4. So if I click on that tag, that gives us a release for the bootloader. So I'll just copy that tag there. I'll go back into my command prompt, and basically what I'm going to do here is say git checkout, and then I'll check out that bootloader tag there. There we go. So once that has checked out, what we're going to do is also rerun this command here. Basically, we also want to update all the submodules to match the version of the tag we just checked out. So I'll just click enter there. I'm going to run the build script in Docker. So instead of running debug.sh, we are going to run release.sh, and I'll hit enter. Now, so let's just check the checksum of what was built. If I just say sha256sum.bin/bootloader.bin and hit enter, that will give me the checksum for the bootloader file. Now, the thing you'll immediately notice is that checksum for the bootloader does not match version 2.1.4, but that's because this has a double SHA-256, not a single. So basically, to get this result here, I'm going to have to do another SHA-256 on this hex string here. So I'll just copy that, and I'll just jump onto any random SHA-256 tool. Like this is an online one, it works just fine. I have to make sure I put the input as hex and make sure there's no extra characters around there. But you'll see that once I put in that SHA-256 sum there, it gives me this output here, which I can now see directly matches to the checksum that the Keepkey is expecting for the 2.1.4 bootloader. So that tells us we can safely flash this file here as the bootloader. So just like before, I'm going to hold down the boot 0 button, that's the middle one, as I connect this in. That puts it into DFU mode, so I'll put that to the side. We'll bring up STM32 Cube Programmer, make sure USB is selected, and then hit refresh, and it should find our device, so we'll say connect. And here we are going to first of all start with a full chip erase. So basically once we've done that, we're going to do the same process we did before. So we'll browse to the releases. Because I'm using the same environment as before, these files are now the release binary files. So we'll start off with the bootstrap.bin, starting off at that offset there. Make sure that run after program is unchecked, and I'll say start. There we go, so that is the bootstrap. And now we'll do the variant. I thought that Fox icon was fun, so I'll just use variant fox.bin, and I'll change that 0 to a 1 for the variant. Flash that. Now we flash our bootloader.bin. I'll change that to a 2. Okay, and we could actually stop right there and just use the Keepkey Firmware Update tool to update this, but I'm just going to keep on rolling and also flash the firmware that I just built as well. So that is firmware.keepkey.bin. Now, if you're paying very close attention, you would have noticed I actually made a mistake right there in that the firmware file that I just loaded in was one that I just built from source, which while it's a deterministic reproducible build, the firmware that I flashed on it just then did not have a signature from Shapeshift. So basically the workflow you'd want to do for this part here is to flash the bootstrap variant and bootloader files that you have built from source, but to flash an official firmware binary from Keepkey. As you'll see in a minute, this mistake doesn't actually matter because we can just use Keepkey Updater to get back to an official firmware release. The key thing here is making sure that bootloader matches a known hash, and that did work properly in this process. I'll say start programming. Done. So now that we have flashed all 4 of those things, we can restart our device. So I'll just unplug that, plug it back in. Oop, there we go. This doesn't quite like the firmware, but we are running a Keepkey. All right, so let's just run the official Keepkey Updater. So I'll just hold down the button and plug that in. So there we go. So now we're running the official firmware 2.1.4. It doesn't tell us we're running debug link or anything else like that. And if we try and connect to this now using STM32 cube programmer, we won't be able to connect. So let's just get the latest official firmware on here using the Keepkey Updater. So we'll get rid of that. There we go. We'll just click here, advised by customer support, and we'll just say update firmware. We'll say this Keepkey is new. There we go, confirm on device. We'll just do that. Okie dokie, so we are now running the latest firmware, but I think I might have flashed the wrong file for my variant, which is why I don't have a proper splash screen on here, but that is great. So now we are working, so we can head over to Shapeshift and we can actually just connect this device just like any retail Keepkey. So there we go, so this is our DIY Keepkey. That, as far as all of the official software is concerned, is a retail device. So we are good to go. Now, obviously, if you're planning to use this as a retail device, you probably don't want to leave it, just as a bunch of wires like this. So I'll just quickly chuck this into a case. There we go. So I put it in the sort of, classic don't short it out on the desk kind of case. So that's fun, but we can do better. And we'll try this bigger screen here, which is a 5.5-inch display. All right, so now it is a bit later. I've actually just removed this screen from the board and actually soldered it in to a larger version of the same screen, just using flexible silicon cables there. And I've also hardwired the button in here with a 10K resistor, basically just sharing one of the pins on the button and the negative is on the other one. So I'll just put this in the box. Okay, so this is our DIY Keepkey with our USB-C port there. So let's just plug it in, make sure it all works, and then I'll super glue this button in place and screw the rest up. Ah yes, this plug is not going to work until I have at least one screw in there. So let's just put one in to hold everything in place. There we go, so that's now connected with Shapeshift. It's got me on the login screen, so everything is working correctly. I'll just log in, check the button works. There we go, that's nice. That button is working nicely too. Great, so we'll just glue and screw this together properly. And there we go, that is our supersized Keepkey with a USB-C port and a 5.5-inch screen here, and our original retail Keepkey down here. Both running the same retail firmware. So if you've ever had trouble reading a Bitcoin address off the screen of your device, this is the wallet for you. That is huge, especially when you compare it to something like a stock Trezor One. So there you go, that's everything you need to know to be able to create your own Keepkey hardware wallet just using off-the-shelf parts. I've also added all the information for this process onto a GitHub repository, so if you do need additional information or if there are any future clarifications, corrections or whatnot, this GitHub repo is where they will go. And depending on whether the Keepkey team are prepared to support and encourage this sort of thing, it might also find its way onto the Keepkey GitHub as well. You never know. A great example of the power of open source and even how powerful open source can be if a vendor has not fully disclosed all of the hardware that they used. You know, it's often still possible just to look at the source code, to look at the device itself, and to reverse engineer it anyway. While a lot of what Keepkey offers is very similar to Trezor, you know, I still find them to be an extremely useful device, particularly with the sorts of recoveries that I often do. You know, especially being able to do things like be able to reconstitute a SLIP39 wallet without a SLIP39 device, to be able to load extended private keys into them from things like tap signers, and even just some of the sort of non-standard stuff that a Keepkey will allow you to do easily and securely that can be a challenge on other devices. You know, a fantastic device to have up your sleeve, and again, a great option, particularly if you're someone who wants a really big screen, to be able to add a DIY device to something like a multi-sig setup to remove any trust that you're placing in any particular commercial vendor. If you have any experiences, either good or bad, with Keepkey that you've had over the years, if you've got any questions about trying to use the device or any questions about this process that I've covered in this video, you know, definitely just leave a reply in the comments. I do my best to reply to everything. Other than that, stay safe. Thanks for watching, I hope that was helpful. Hit like if you think that other people would find this video useful, and hit subscribe if you'd like to be kept in the loop about future content I make that helps people stay safe in the crypto space and to recover if they get into trouble. If you have any questions about this video or a topic that you'd like me to cover, just leave a reply.